When you click onto this software, the software look like this. First one is Setup Assistant, which is shown on your screen. It is the fastest way to create custom project. Take a tour. It shows how to use HOMER Pro interface. Third one is sample files. It gives you the result of example projects. And in the final steps, continue to HOMER Pro without help. So you can choose any options. If you are a learner, then you can go with this Setup Assistant and take a tour. It guided you how to create your custom projects. So first of all, close it. For running this software, we must need it to internet connectivity. Without internet connectivity, we can't run this software. Onto the top of the screen, this is called ribbon bar. And in this ribbon bar, we have different types of tabs, and each tabs have different functions, tools, discussed about all tabs and components. When you click on to load, then we have different types of loads: electric load first, second, deferrable, thermal load first, thermal load second, and hydrogen. Similarly, when you click onto the components option, then you can see we have different types of components: controller, generator, PV, wind turbine, storage, converter, custom, boiler, hydro, reformer, electrolyzer, hydrogen tank, hydrokinetic, grid, and thermal load controller. Similarly, when you click onto the resources, then we have different types of resources: solar GHI, solar DNI, wind, temperature, fuels, hydrokinetic, hydro, biomass, and custom resources. When you click onto this project option, then it have different types of tools and options for economics, constraints, emissions of gases, optimization, search space, sensitivity, multi-years options, input report, estimate, and a clear results option. When you calculate anything, and if you want to clear everything of the results, then simply click this onto this icon. If you want to help onto this software, so you can click onto the help tab and go help. I click onto this help icon and see the help for this software. Take tool, which discussed in the starting of this software. Setup assistant already discussed about of this software. So when you click onto this, then you can see the details of this HOMER Pro software. And also you can see the license information of this software. So first of all, close it. All the pages of HOMER Pro divided into two parts. First one is a schematic and required changes, and second one is design page. If you want to create your first new project, so simply click onto file and go to new projects. So we have already new projects, and otherwise if you want to go new again, so click here. Anytime you can go onto the design page and result page. HOMER provides, we have different types of libraries we discussed at the end of this presentation. In the schematic, your project component added with AC and DC sources. In this required change, in this section, HOMER guided the basic steps in starting and also during whole projects. In the design page, in this section, you can see the location of search. At this point, you can search your location. Second one is resources. Download the resources from the internet using this resources option. So first of all, click onto these resources. When you click onto these resources, then we have different types of resources for solar, wind, and turbine. Sorry, temperature. So click onto it and download these resources. Now you can see the information. The resources were downloaded successfully. So press OK. You can give the project name, author name, and the descriptions. You can give the descriptions of the projects. Now go to the left menu bar in required changes. So in this left menu bar, you can see the first option is add a load. So click onto this option. When you click onto this add a load, then in this design section, you can see we have an option to pick a month. So you can choose your peak months for Jan and July. So click onto Jan. Second one option is profile option. And we have different types of profile option when you click onto this icon for residential, commercial, industrial, and community options. So it depends on you for which purpose you want to create your system. So you can choose anyone, click onto residential and press OK. Now you can see your design page is changes, and in the schematic, your electric load is connected with AC sources. In this required change, we also guides again to add a power source. So click on to add a power source. In the design page, when you click onto the auto size genset options, you have different types of genset. Generic 10 kilowatt fixed capacity genset, 25 kilowatt fixed capacity genset, 50 kilowatt fixed capacity genset, and so on. So you can use any genset according to your need and for your custom projects. So we chooses here 10 kilowatt fixed capacity genset and press on to add a generator. Now this software suggests that add a renewable energy sources in this suggestion options. So click onto it. Now in this design page, you can, when you click onto the concentrating PV option, we have different types of PV. So please click here. Then you can see we have different types of concentrating PV. And first of all, one is the generic flat plate PV, concentrating PV, starter value track VT, and so on. So click onto the flat PV, press on add PV. After adding of PV software requires changes. So again, click onto the add converter. Now in this design page, when you click onto the system converter, then you have different types of system converter, generic large free converter, Leonis MTP 413F 25 kilowatt, and so on. So click onto the system converter. On the top of right corner, the calculate button is activated. You can see here. Now click onto the calculate button. When you click onto it, then Homer calculate for lowest net present cost. We Sorry for this convenience. It's happened due to the internet connectivity. So am I audible properly?
Yeah, now you are audible.
Hello.
Yes, yes, now you are audible.
Okay, thank you. So you can see the cost summary of this results. Again, I want to show the base case indicated by black color and the lowest cost system indicated by blue color. So you can compare the base case and the lowest cost system summary from the right hand side of tables of your screen. The net present cost of the base case is 2,10,096, but the lowest cost system net present cost is 1,71,564. So it is very big difference between the net present cost of base case and lowest cost system. The initial capital cost for this base case is $5,000, and the lowest cost system is $35,400. Operation and maintenance cost for this base case is $15,865 per year, and for this lowest cost system, this value is $10,533 per year. Levelized cost of energy uh, for the base case is $3.96 per kilowatt hour, and for this lowest cost system, this value is 3.23 per kilowatt hour. Anytime if you want to go to design page, simply click here and go to the design page. If you want to add another components in this circuit, select components tab in the ribbon bar and choose those components which you want to add in this circuit. So go to the component tab. In these components, we have different types of components. So click onto the wind turbine. When you click onto the wind turbine, then in the design page, you can see a wind turbine pages option open on your screen. And when you click onto this option, then we have different types of wind turbine. So is the capacity of 1 kilowatt, for 3 kilowatt, 10 kilowatt, 1.5 megawatt, and so on. So you can choose any one and click onto the add wind turbine option. Now click onto the storage options into the components option. And in this design page, again, when you click onto this icon, then you can see we have different types of storage. So you can choose any storage according to your need and press on to add a storage option. By single click on each components of a schematic, and you can see the component properties which are used in this system, and also you can put other value for another results. So when you click onto the generator, then you can see the property of the generator, the name of component, capacity, which type of fuels uses in this generator. If you want to change the fuel, then you can first of all click onto the advanced option. And when you click onto this advanced option, then a new window will open on your screen. And here you can see the fuel resources. In this fuel resources tab, you can select fuel from here. We have different types of fuels: diesel, Arctic heating oil, biodiesel, biogas.
So, respected sir, sorry for interrupting you. Could I have some question?
You can ask any question at the end of the presentation. If you, but
Okay, okay, that is okay.
okay, thank you, sir. So from here you can use your choose your fuels onto click onto this icon. So click here diesel for Arctic diesel, Arctic heating oil, and biodiesel, HFO, methanol, natural gas, stored hydrogen, propane, LPG gas, and so on. So you can choose anyone and press OK. Similarly, when you click onto PV, so in this design page, you can see the property of this PV. We have the name of this PV and other details of this PV components. You can add any data in this PV and other components. When you click onto this mode options, then we have a new cost table open on into your screen. The capital cost for this 1 kilowatt capacity is $2,500, and the replacement cost for this capacity is $2,500, and operation and maintenance cost per year is $10 per year. So you can add another value in this system. So click onto this value and you can type here for the capacity for 2 kilowatt, and when you click onto it, then it's automatically read the capital cost and the replacement cost according to the capacity of 2 units. Similarly, when you click onto the wind turbine, then you can see the wind turbine details onto your screen, the properties of the components, name, and other details. Similarly, if you want to add another details for this wind turbine, simply click onto this, click here to add a new item, and type here for the second quantity, third quantity, and the capital cost for this quantity, and the replacement cost for this quantity, and the operation and maintenance cost is $180 per year. So you can add the quantity and capital cost for the second quantity and replacement cost. If you want to change the electric buses, then you can simply go to the left hand side of this option, electric bus, and you can adjust this wind turbine from AC source to DC source. Simply click onto DC. Now you can see your wind turbine is moved from AC source to DC source. Okay, so you can do it. Yeah. Similarly, when you click onto the converter, then you can see the property of the converter. Also, you can add the cost in the cost table of capacity for 1 kilowatt. Capital cost is a $300. Replacement cost also $300, and the operation and maintenance cost is $0 per year. So you can also add here the value of for the 2 kilowatt capacity. Simply click onto this and type here 2 kilowatt and type the value of 600. Also here $600, and its value is 0. For removing these details, click onto this. When you click onto this storage, then you can see the storage properties, name and details of this storage, name of the components, and also you can see the cost quantity, capital cost of the quantity for 1 unit is $300. Replacement cost also $300. Operation and maintenance cost for this storage for 1 quantity is $10 per year. Simply click onto this more options and you can add the value for second quantity, third quantity, and so on. Press OK. So again, go to PV options, and in this PV option, click onto the more option, and you can see here we have already the value for 2 kilowatt capacity. Capital cost is $500, and replacement cost also $500, and the operation and maintenance cost is $20 per year. Press OK. And it's all things for the 25 years. If you want to add another more years, so simply click onto this option and go to these boxes, double click onto it and type here for 30 years, 35 years, 40 years, and press OK. Otherwise, delete this value. And now recalculate this value. HOMER Pro use the HOMER optimizer property algorithm to search for the lowest net present cost system for your load and location. This may take a few minutes as HOMER searches thousands of possibilities. The blue line traces the net present cost as Homer searches for an optimum. Once Homer has finished its optimization, you will see the results tables. So please wait. If you have any queries, then you can use chat box and type your question in the chat box. I will try to give your question answers. It takes few minutes to complete the actions. It's optimize the lowest net present cost for the system which you developed. In this result tables, you can see the base case and the lowest cost system and the cost summary of this base case and lowest cost system. Base case indicates by black color and the lowest cost system is shown by blue color. The net present cost for this base case is 2,10,096 rupees, sorry, in dollar. And the lowest cost system you will create in the only for $33,741. The initial capital cost for this base case is 5,000, and the lowest cost system is 19,037. Operation and maintenance cost for this base case is $15,865 per year, and for this lowest cost system, this value is very less in the compared to the base case, $1,137 per year. The levelized cost for this cost of energy for the cost base case is 3.96 kilowatt hour, and for this lowest cost system, this value is $0.636 per kilowatt hour. So you can see and compare the base case and lowest cost system in the cost table. The system which used in this the lowest cost system, we use a generator, PV, storage, and a converter. But in the base case, it's used only a generator, and due to this generator, the value of the base case of net present cost is very high in compared to the lowest cost system. Anytime you want to change the base case, then simply click onto this. Then you can see we have different types of base cases. Say at this time, we have this software give the options to choose this way. In this way, we have a PV, storage, generator, converter, and due to this, the net present cost for this is $33,741. And the compare of the base case, which indicates in the last of this option. And in this base case, this use only a generator, and due to this, the net present cost of the base case is 2,10,096. You can compare from any design of the architecture. So in this option, we have all types of components. So you can simply click onto it and press OK. It takes again few seconds to calculate the results. Now you can see the results and difference of the net present cost of this base case and lowest cost system, and its difference is some different, not more difference in previous system, because in this system the system uses a generator, PV, storage, and a converter, but in this base case it's used to generator, PV, storage, converter, and a generator. Due to generator, this value is higher than the lowest cost system. And also the initial capital cost is increases in compared to the first way. And the operation and maintenance cost is $1,774 per year. And levelized cost energy for this base case is 0.902 per kilowatt hour. And for the lowest cost system, this value is $0.636 per kilowatt hour. So you can change your base case anytime. It's this table comes onto the categorized option. When you click onto the overall options, then you can see we have different types of choices to create your base case and lowest cost system, and compare the value for net present cost from base case to lowest cost system. So you can choose anyone. Now close it. The comparing base case at the initial of this. So please press on to this. When you click onto the table option, then we have optimization results of tables, and you can also see these tables in this previous card. And when you click onto this overall, then all types of optimization results comes over your screen. If you want to export this value, simply click onto it and save the file name in your system, and click onto this option and save your details. Now close it. For when you click onto this compare economics, then it's again shown, which see in the previous tab. So you can compare again. When you click onto this graph options, then it's shown different types of graphs onto your screen. At this time, not enough sensitivity is variable, so you can change from here and plot your graph. For this, not options of the graph, yeah. Now you can see the graph of total operating cost and the total present cost, sorry, capital cost, and the graph indicates onto your screen. You can change for X variable and the Y variable in the total net present cost, operation and maintenance cost, cost of energy and total fuel. Similarly for the Y variables and base cases. So click on to again summary details. If you want to see the simulation details of the whole system, so click onto it. When you click onto it, then you can see a new window open on your screen, and you can see different types of options and tabs in this window. When you click onto cost summary, then the cost type by net present cost and by components, you can see the cost of the generator. Moving your cursor onto this icon and table. So the cost of the generator is $8,002.83. For this storage, the value is $16,503.955. For PV, $8,545.11. And for the system converter, this value is $688.66. When you click onto this annualized option and by cost type, then the capital cost for the system is $1472.61. Operating cost is $271.60. Replacement cost for the whole system is $779.03. and you can save $148.67, and the fuel charges during this in this system is $235.45. You can see the component's name, capital cost for the component, replacement cost for this component, operation and maintenance cost for this component, fuel price which using in the generator, save value, which how many dollars you can save using this type of system, and overall cost of the system. The capital cost for this generator is $386.77, and when you have not any replacement value, operation and maintenance cost for this generator is $559.10, and fuel cost which uses in this generator is $235.42, and you can save $62.23 with using this generator. And the total cost for this generator using fuel and after saving this value is $619.05. Similarly, for this storage of battery, the capital cost is of this battery is $417.70. The replacement cost for this battery is $762.21. Operation and maintenance cost is $180. Fuel cost is $0. You can save $83.28 with the using of this battery, and total cost for this battery is $1,276.65. For the generic flat PV, the capital cost for this PV is $628.50. No any replacement cost for this PV. Operation and maintenance cost is very less in compared to this battery, is $32.50. No charges of fuel. With the help of this PV, you can't save any value, and overall total cost for this PV is $661.00. For the system converter, the capital cost for this system converter is $39.62. Replacement cost is $16.81, and operation and maintenance cost is $0. Also, it can't use any fuel, so this value is also $0, and you can save $3.16 using this system converter, and overall total cost of this system converter is $53.27. And the entire system capital cost is $1,472.61. Replacement cost is $779.03. Operation and maintenance cost is $271.61, and fuel prices in this system is $235.42. And using this system, you can save $148.67, and overall total cost for the entire system is $2,609.98. Similarly, when you click onto the cash flow, then it's by the chart value you can see the cash flow diagram by cost type. When you click onto this, also by component type and discounted type. So first of all, discussed cash flow nominal and by cost type. The color indicates the replacement for fuel, save value, operating value, and capital cost. This indicates the capital cost, and this color indicates the replacement cost in the system. By table, you can see the capital cost and capital cost, operating cost, save value, fuel value, and replacement value from 0 hour to 24 hours onto your screen. So by table, you can see the details and nominal cost and generator using cost of different types of fuel and other details of the generator, storage, PV, and system converter. So you can see using bar chart. By component type, you can see the system converter color indicates generic flat PV indicates by this color, storage indicates by this color, and the generator indicates by this color, which indicates shown on your screen. You can see easily. Similarly, when you click onto this compare economics, so you can compare here the net present cost of base case and the lowest cost system. It's also called proposed system. So you can use this system to create your system, and you can create your proposal in compare to this base case. The present worth in dollar is the value is $176,355. Annual worth per year is 13,642. The return on investment in percentage is 101%. The rate of return, internal rate of return, is 101.1, and simply payback year is 1.08. Discounted payback year is 1.14. When you click onto electric, the production of by the PV, it's using this PV, you can produce 5,545 kilowatt hour per year, and it's the percentage is 91.8. With the using of this generator, you can see this value is 492 kilowatt hour per year, and its percentage 8.16. Overall total value is 6,038, and the percentage 100. Consumption of AC primary load and DC primary load and the variable load. The AC primary load per year is 4,105, and the percentage 100%. And also the total value is same because no any DC primary load and the variable load. Quantity of excess electricity in per year is 1,187, and the percentage is 19.7. The quantity of renewable function is 88%, and maximum renewable penetration is 1,435%. This color indicates for PV, and this is indicates for generator. The graph between megawatt hour versus months. So when you move your cursor onto this block, then you can see for the PV for Gen, also for generator for Jan. Similarly for February, March, and up to December. And this is monthly electric profile. In this monthly electric profile, the using of PV, you can generate your electric value in January, February, March, and up to December. When you click onto this fuel summary, then in the fuel we have used the diesel. So you can see the fuel summary of this diesel. The quantity of fuel comes up is total fuel consumed in this system is 235 liter. Average fuel per day is 0.645 liter per day, and per hour is 0.0269. You can see the fuel profile from Jan to December, liter per hour to this month. When you move your cursor onto this block, then you can see the value. And this is fuel consumption profile, and it's a draw in the hours of day versus day of year. The color indicates from 0 liter per hour to 0.24 liter per hour. It indicates from black to blue, from 0.24 liter per hour to 0.48 liter per hour. it just rises from blue to green. From 482.72, it's moved from green to yellow, and from 0.72, it's moving from 0.96. The color indicates by yellow to dark, orange, and from 9.96 liter per hour to 0.12 liter per hour, it indicates by red color. It means at this time, the consumption of fuel is very high. And when you move your cursor onto this graph, then the value indicates at this time, all these places are indicates by black color. It means at this point, no any fuel usage. And you can also see this value in these boxes and the day, time, month, and particular year. When you move your cursor onto this red icon, red color, then you can see this value is 1.20 liter per hour. And at this time, the fuel consumption rate is very high. Also, this graph is from liter per hour to this month. So you can see the fuel consumption from Jan to Feb is very high. And also if this value is increased, and sometimes it's increased up to April's, and after that the value is just less, and the gapping is just large in compared to the Jan, Feb, March. So you can see the diesel profile. When you click onto this auto size genset options, then the hours of operation of this generator, 197 hours per year. Number of starts of the generator is 192 starts per year. Operational life is 76.1 year. And capacity factor for this genset is 0.562%. Fixed generation cost for this genset is $1.11 per hour. Quantity of electrical production is 492 kilowatt hour power per year. Mean electrical output from this genset is 2.50 kilowatt. Minimum electrical output 2.50 kilowatt, and maximum electrical output also 2.50 kilowatt. The fuel consumption using this genset is 235 liter, and a specific fuel consumption is this value is 0.478 liter per kilowatt hour. And fuel energy input for this generator is 2316 kilowatt hour per year. Mean electrical efficiency for this 21.3%. The generator power outputs also color indicates the value of power from 0 kilowatt to 0.5. It indicates by black to blue. From 50 to 1, blue to just green. 1 to 1.5, it's just moving from green to yellow. 1.5 to 2.0, it's moving from yellow to red. And 2.0 to 2.5, this value is much higher position. So this is maximum electrical output color. And also when you move your cursor onto this graph, then you can see the value. At this point, this is black color. It means no any electrical output. So this value is 0. When you move your cursor onto this red color, then at this point, the electrical output is 2.50 kilowatt. And it is higher point. Similarly, when you click onto this renewable penetration, then in this tab, you can see the graph of different types of generation. So the capacity based matrix, nominal renewable capacity divided by total nominal capacity, the value is 24.5%. Usable renewable capacity divided by total capacity is 20.6%. And energy based matrix for the total renewable production divided by load is this value is 135%. Total renewable production divided by generation, this value is 91.8%. and 1 minus total renewable production divided by load is 88%. The peak value of renewable output divided by load is 1435%. The renewable output divided by total generation is 100%, and 1 minus non-renewable output divided by total load is 100%. Also, color indicates the value. The instantaneous renewable output divided by generation. At this point the value is 100%, and this is the higher value, and at this point this is zero, and it's time no any renewable outputs. So instantaneous renewable output divided by load, the graph indicates by the color 0 to 320, 320 to 640, 640 to 960, 960 to 100, 1280, and at the higher values 1600. So at this very less time, the value is very higher at this point, and this value is 133.95, and it comes in the area of 0 to 320. The graph of 1 minus instantaneous non-renewable divided by load, the higher value is from 100 to 500, and below this is negative value. And when you move your cursor onto this color, then you can see the color indication. So 1 minus instantaneous non-renewable divided by load, you can see the graph. Similarly, when you click onto this storage option, the quantity of battery users in this entire system is 18. A string size is 1 batteries, and a string in parallel is 18 strings. The bus voltage of this battery is 12 volt. Quantity of autonomy is 23.1 hour. Storage wear cost for the system is $0.419 per kilowatt hour. Nominal capacity cost. So nominal capacity for this battery is 18 kilowatt hour. Usable nominal capacity is 10.0. Lifetime through output is 14,400 kilowatt hour, and expected life is 6 years for the battery. Quantity and the value of average energy cost is 0. Energy input is 2,674, and for output 2,147 kilowatt hour per year. Storage depletion is 9.08 kilowatt hour per year, and losses is 536 kilowatt hour per year. You can see the graph of frequency, and when you move your cursor onto this block, then you can see the value on your screen. The graph of state of charge, hours of day versus year, and the color indicates from 40% to 52%, black to blue, 50 to 64%, blue to green, 64 to 76, green to yellow, 76 to 88, it's on red position, and 88 to 100, it's maximum position of state of charge. You can also see the value on this color when you move your cursor onto this color. A state of charge of plot of the graph of Jan to December onto your screen for this storage. When you click onto this flat plate PV, then you can see the details for this PV. The rated capacity of this PV is 3.25 kilowatt. Minimum output from this PV is 0.633 kilowatt. Minimum output per day is 15.2 kilowatt hour per day, and the capacity factor is 19.5. Total production with this PV is 5,545 kilowatt hour per year. The quantity of minimum output, the maximum output is 3.14 kilowatt. The PV penetration is 135%. Hours of operations 4,380 hours per year, and the levelized cost of this PV is $0.119 per kilowatt hour. Color indicates the value of production. From 0 kilowatt to 0.7 kilowatt, it's black, and from 0.70 to 1.4 kilowatt, black to this color. 1.4 to 2.1 kilowatt, it just rises and moves another color. 2.1 to 2.8, it's indicates by yellow color, and from when it's at the peak value, the PV power output is 3.5 and it indicates by yellow color, dark yellow. Okay, so you can see this value. At this point, the value is 2.9 kilowatt. And the PV power output at this point is 3.06 kilowatt. And at the black color, no any value of the PV power output. When you click onto this system converter, then you can see the inverter or rectifier output graph, and the quantity capacity for this inverter is 1.71 and the rectifier is 1.71. Minimum output from the inverter is 0.46, and for the rectifier this value is 0.0293 kilowatt. Minimum output for this from this inverter is 0 and also 0 for this rectifier, and the maximum output for this inverter is 1.55, and for the rectifier this value is 1.71. Capacity factor for this inverter is 26.1, but the rectifier is this value is 1.72% only. Hours of operations of the inverter, it works for 8,563 hours per year, but the rectifier it works only for 197 hours per year. Energy output from this inverter is 3,906 kilowatt hour per year, and from the rectifier this value is 257 kilowatt hour per year. Energy input with the help of inverter is 4,111, and from the rectifier this value varies in compared to the inverter, and this value is 270 kilowatt hour per year. Losses from this inverter is 206, and but from this rectifier this value is 13.5 kilowatt hour per year. The inverter output graph, and this is rectifier output graph, and color indicates the output of energy from 0 to 2 kilowatt, and color indicates from black to blue, blue to green, green to yellow, and yellow to red. Last one is when you click onto this emission, then you can see the gases which emits from this system. So you can see the emission of carbon dioxide gas is 615 kilogram per year. Carbon monoxide emits 4.65 kilogram per year. Unburned hydrocarbon is emits 0.169 kilogram per year. Particulated matter emits 0.282 kilogram per year. Sulfur dioxide is 1.51 kilogram per year, and the nitrogen oxides is 5.29 kilogram per year. This is the emission of the gases from this entire system. In the top of this screen, you can see the architecture of the lowest cost system which you created, and in the system you use the flat PV 3.25 kilowatt capacity and the generator of 10 kilowatt capacity, battery of 18 strings, system converter is 1.71 kilowatt capacity. If you want to plot the time series plotter graph, then click onto it. You can see the hourly graph of the kilowatt versus month from Jan 1 to December 31st, and color indicates the total electrical load saved by this color. And at this point, you can see the value when you move your cursor. Different colors show different things of this. This color indicates for the generator. It's for PV, and last one is for the battery. So you can see the graph of the battery kilowatt versus month. When you click onto any particular color, and also no, you can zoom in and zoom out to for clear vision. Yeah, at this point you can see two colors, and it indicates the value on your screen. At this point, it's just moving, rising from the value, and at the peak point, after the peak point, it's go back and down again. Okay, you can also see the monthly profile, and you can change the axes in which versus which. So at this point, this indicates why global solar versus monthly annual average. When you click onto this PV, then according to this PV, the monthly profile and every monthly average profile shown on your screen, and you can see the value of annual maximum, day average maximum value, average value, and day average minimum value, annual minimum value for the particular month. Moving your cursor, monthly profile of the PV solar for January, February, March, April, May, June, July, and up to December. You can also see the deep map of the system. For PV solar altitude, and for the global solar, and also the color indicates the value from 0 to the upper value is 1.4 kilowatt per meter square. Histogram map, CDF map, and DC graph onto your screen. And you can change the global solar to PV solar altitude, and so on. We have different types of options for AC primary load options. So you can see the graph of AC primary load duration curve, AC primary load versus time stops. Now close it. Also, if you want to draw the scatter plotter, simply click onto it and see the scatter plotter of the graph. You can change the plotter. Close. At this time, this plot in the global solar versus global solar. So you can change from here AC primary load versus global solar for month. You can change the profile from Jan to December. In this December profile, you can see the graph like this for July. We have different types of options. You can use total renewable power output versus global solar, and you can see the graph. Otherwise, close it. You can plot the delta plotter. For the global solar, you can increase for 0 hours to 24 hours, and according to your interval length, the graph change its frequency. Next one is when you again click onto these other options, then you can see the tables, output time series tables from January to December, and this value is from 1 a.m. to 24 a.m. and this value is repeated, so time is repeated from 1 a.m. to 12 p.m. Again, its value changes from another day, and you can see the each and every details of the entire system for the global solar, generic flat PV, solar, and other details, output factor, AC primary load subbed, and so on. If you want to export this data, then go to export option and save it, otherwise cancel. And last one is copy. You can simply copy this option, and you can add it into the WordPad and other tables at which you want to add. So if you are satisfied with this system, then you can go to create your proposal. So click onto it. In this option, you can give the silent name of the project information, title of this project address, and press onto next option. Give your name, title name, and other details. Again, press next. You can select title sections. We have different types of options. You can choose and press onto next. And you can choose your report format in letter, A4 size, and legal, and open a report. So this is entire details of this software. So one question is which optimization method is used? In this system, HOMER automatically used this option method to calculate the results. This software used to optimizer proprietary algorithm method to find out the different types of results. Now let's move forward to the another features of this software. When you click onto this file options, then it's shown we have different types of options. For new, you can see we have different types of samples. So when you click onto open samples, and also you can save your projects which you create. Simply go to save as and save your project onto this system, otherwise close it. So you can go to the sample files, simply click onto it, and when you have different types of samples in this software, you can see on your screen we have different types of options and the samples. Again, it indicates that if you modify your save change, then you can press and go to these options, otherwise close it. So I don't want to modify anything. Yeah. This is a sample example of the system which is provided by HOMER Energy. In this schematic, you can see the system used two types of generator, two generators, sorry, generator first and generator second. You can see the details of the generator for first generator and the second generator, the same property of the both generator. electric load. In this system, it's use the wind turbine and heat sink, thermal load controller, and thermal load. This graph of the general profile depends on this value. When you change this value, this graph also change. At this particular point of 6 value, this is 188.140. When you change this value, just 200, then you can see the graph change from 188 to another value for 209. At this time, you can see the values for this 12. This value is 334 and 0.47 kilowatt at the time of 14. So when you change this value, press enter, then you can see the graph also change. The seasonal profile of the system for general profile, yearly profile, and color indicates on your screen. When you click onto this calculate result, then you can see we have different types of color indicates the value of replacement cost, fuel cost, save value, and operation value. And in this system, this is example, so you can't change any another value. Anytime if you want to go to design page, simply click onto it and go to here for go to result option, click here. Okay. In this software, if you want to remove any components during this custom project and create your project, click onto any components, and in the design section you can see here the remove option. So when you click onto remove option, then the component automatically removed from this schematic. You can see we at this time we have only one generator, and in the previous time we have two types of generator 1 and generator B. So at this time we have only one generator. So you can using this option, you can remove any components from the design page. Let's move on to this library function of this software. So when you click onto this library option, then HOMER provides much types of library. In the components, we have different types of component which provided by HOMER: controller, generator, storage, PV, wind turbine, converter, custom components, hydroelectric, hydrokinetic, thermal load controller, boiler, reformer, electrolyzer, hydrogen tank. In these resources, we have different types of resources which provided by HOMER. Manufacturer, different grids and simulation parameters. It's given by the HOMER. If you want to import, click onto this option and importing these value files in this system. Next one is when you click onto components and go to controller, then in this design page, you can see here we have different types of link: HOMER cycle charging, HOMER load following, and HOMER Pro MATLAB link. So if you want to go to work onto this MATLAB link, simply click onto it and click onto add option and copy your link options and paste here, and you can simulate it for MATLAB link. So you can use this software. Yeah. If you have any queries, then use your chat box and ask the questions. I will try to give you your question answers. Custom resources, mainly custom resources is sometimes we moves forward And just I want to show you. Sometimes we can't download these resources, and moving forward for create your system just like this. Then it's shown the solar GHI resources is required. So when you click onto it, then it provides you to download from internet directly. Okay. So from here you can download. Otherwise, if you want to learn from this software more, then you can choose and download this software for demo version for 21 days free of cost without any postage. So in the last of this session, we discussed how to download this software. Let's move on to this HOMER Grid software. When you HOMER Grid, then the software look like this. Just wait. Is any other queries? Please ask using chat box.
Okay, sir. This is Brijen. So, are you able to listen me? Am I audible?
Sir, please your chat box, please, sir. Please mute your mic and use chat box to ask any question. I will try to give your question answer. Who developed the HOMER Pro? HOMER Pro is mainly developed from the HOMER Energy. And if you want to see more details and details of the HOMER Pro software, then you can go visit onto this Chrome site and type where HOMER Energy. Then you can see each and every details of HOMER Pro and HOMER Energy. Okay. So this is the what relation, whatever the relation of Delsoft. Mainly we will dealer of this software. If you we deals this software from to HOMER Energy, and we are the dealer of this software. If you want to purchase this software, then you can contact with us for this software. So let's move forward to this HOMER Grid software. It's also give you the setup assistant, take a tour, see sample files, and if you know these details, and so you can go with HOMER Grid options directly. Otherwise, close it. The software look like this. Delsoft also develops software. No, Delsoft don't develop this software. We provide this software. If you need it, then you can contact with us. Delsoft is only dealer of this software. So the interface of this HOMER Grid you can see onto your screen. In the middle of section, this is a schematic options and drawing and design page. In the left hand side, you can see the library for setup, electric load, utility, different types of components in HOMER Grid for PV, storage, converter, generator, and wind turbine, and other types of tabs for outage, programs, resources. We have different types of resources in this HOMER Grid also for solar GHI, PV production, fuel and temperature, and also for wind, CHP, and electric vehicle charging, and projects. In the right hand side, this is setup assistant, and in this right hand side you can also see the draw of a schematic and your project. Anytime if you want to go to design page, click onto this icon, and also you can select results option to give see the results. You can search your location, give your author name, your name, description about this software. It also guided you to required changes. It gives the required changes, and until it's removed from red color to green, you go from this way. So it guide you to add a primary load. Before adding a primary load, we must need to add resources. So click onto resources. We have different types of resources for solar, wind, and temperature. So click onto it and download. Now click on to add a primary load. In this software, we have different three types of option to import your files. But in this in the HOMER grid, we have only one options. In this HOMER grid, you have three options to import your files. So if you have already in this system, in your system, then you can go from import option and you can import your load from your system. Otherwise, you have second option to download this, and third one option is you can choose from your load profile. So at this point, we again choose a residential for January and press OK. You can see the January profile of from 0 hour to 24 hours. And the load from 0 hour to 24 hours, yearly profile of this graph, daily profile, and the seasonal profile of this month. Also, you can see it for another months, for Jan, Feb, and another weekends for February, and so on. Next one is add a utility. So click onto it. Go to simple tariff. And you can give here the energy charge, just 2 rupees per kilowatt hour. And the demand charge is 4, and fixed charge is just 8. Press OK. In this case schematic, you can see the grid primary load is added with this AC sources. When you click onto consumption, then you can see the energy charge for 2 rupees per kilowatt. Import rate is, and the season and time of use is always. You can see the graph. Now moving forward to add a PV. So click onto it, and we have different types of PV. So select here and press OK. The capital cost for 5 kilowatt is, the value is 16100 rupees. Replacement cost is 16100 rupees, and the operation and maintenance cost is 100 rupees for 10 kilowatt, for 1000 and 2000. You can add another more value, simply click onto it, and otherwise you can delete. Okay. Now click on to add a storage. Again in this design page, and click here, you have different types of options to add a storage. So click here and press OK. For the one quantity, the capital cost is 300, the replacement cost also 300, and operational and maintenance cost is 10 rupees per year. The system requires to add a converter. So click here and add a converter from this page. Click onto it and select system converter. If you want to add another more components, Then go to components option in this library and add another components. So if you want to add wind turbine, generator, converter already added here. And but you want to add generator, so click here and select auto size genset. We have different types of genset, so 10 kilowatt and press OK. After adding this generator, go to results and calculate. It takes few minutes to calculate the results, so please wait. Is any other more queries regarding the software? Please use your chat box. Until this process is completed, we will discuss how to download this software free of cost for 21 days for free trial. Simply go to Chrome and type here HOMER Energy and press enter. Go to HOMER Energy page. HOMER Energy have three types of products: HOMER Pro, HOMER Grid, and HOMER Front. We deals with HOMER Pro and HOMER Grid. If you need this software, then you can contact with us. And in the last of session, we once again give you the way how can you contact with us. So you can choose anyone, and also you can use both of the software. So first of all, we must to create your accounts onto this software, onto this site. So when you click onto the sign in option, then it gives you don't have an account and create one. So if you don't any account, then first of all click on to create one and give your email address, password and confirmation password and sign up here. When once again you once you sign up here, then you got on an options to download this software. Go to product. So from here you can download this software. Click on to HOMER Pro. At this point you can see they start your free trial now, and it's available for 21 days, 1 day free trial, and you can download this software from this place without any cost. So you can use this software. Similarly, if you want to use this HOMER Grid, again click onto here and you can use this software one also for 21 days free trial. For trial, click trial option. Otherwise, if you want to buy, then go to buy option, and it must be create your account onto this site to download this software. Is any other queries regarding this software? Please ask. Yeah. You can see the base case of this system and the proposed case, lowest cost system, which you create. The net present cost for this base case of the cost summary is the value shown on your screen in these rupees. And for the lowest cost system, this value is very less in compared to this base case. The initial capital cost for this base case is 0 rupees, but the lowest cost system is 22,165. But this software only used to finding out the lowest net present cost. So we mainly see the value of net present cost of base case and lowest cost system, and this value is very different from the other. The saving per year using this lowest cost system is 7,821 rupees per year. The net present utility bill saving is 1,103. The annualized demand charge saving is 86.40 rupees, and the annualized energy charge saving is 7,734 rupees. You can change your base case using these options. At this time, your base case is this, and in this architecture, we use only a grid, and due to this, the value is net present cost is very high. In the last of option, if you use it and compare from this lowest cost system, then you can see the value is higher in compared to the previous base case. So you can choose another base case and compare your value, the categorized value and overall value. In the overall value, we have thousands of results which optimized by this software. You can see on your screen. Lots of architecture in this table. You can compare from anyone, otherwise close it. When you click onto table, then you can see the optimizing table and results. Similarly, you can see the graph change from here and see the graph. For know any graph for this value, you can choose any one by one and see just like this. Anytime you can go onto this design page and go to results page. Again, click onto summary. When you click onto simulation details, then you can see the simulation details of the each and every components by component types, by year, and categorized by cost. For the generator, sorry, for the storage, the capital cost is for the value shown on your screen 14082.03. For the PV, the value is 17995.29. Simple tariff is 7,400 to 27.50, and for the system converter, this value is 543.58. The capital cost for this storage is 5,100. Replacement cost for this 7,278.66. Operation and maintenance cost, fuel cost, no any fuel usage in this storage, so this value is 0. You can save for 194.31 rupees, and overall total cost for this storage 14,082.03 rupees. For this values for the capital cost, replacement cost is 0. Operation and maintenance cost is 1,334.48. Fuel cost is also 0, and you can't save any rupees using this PV, and total cost for this PV is 17,995. Okay, for system converter, capital cost, replacement cost, operation and maintenance cost, fuel value, and save value, and total cost. Overall system capital cost is this. Replacement cost is 7,450.21. Operation and maintenance cost is approx 10,959, and overall total cost for this entire system is 40,048. And you can see the total net present cost is same entire system. You can see the cash flow table by chart, by table. Compare economics from base case to proposed system. You can draw the chart for proposed system in nominal by base case nominal. It indicates total value for the proposed system, and it indicates for total value for base case system. This is cash flow chart. When you click onto this table, then you can see the details for nominal cash flow, proposed system, and base case system, and the difference of annually. Discounted cash flow for proposed system and base case system. Difference between proposed case system minus base system for nominal. Similarly, you can select another options to see. When you click onto electric tab, then production of energy with the help of PV is 7,786 kilowatt hour per year, and this value is 97%. Grid purchase is 238 kilowatt hour per year, and this is 2.97%. Total value is 8,024, and it is 100%. This color indicates the utility of January, and this is for PV for January profile, February, March up to December. Consumption of AC primary load kilowatt hour per year, and in the percentage, AC primary load is 4,105, and the percentage 55.6. Grid sales is 3,279, and the percentage is 44.4, and total kilowatt hour per year is 7,385, and it's 100%. Excess electricity quantity is 0, and the quantity of renewable function is 96.8%, and the maximum renewable penetration is 3,317%. For storage, you can see the battery value and units, strings, parallel strings, the graph of hours versus years. The quantity of autonomy is 21.8 hours. Storage wear cost, nominal capital, and usable nominal capital is 10.2 kilowatt hour. Expected life is 6.95 year for this system. For this storage, the quantity energy input is 2,186 kilowatt hour per year. Energy output is from this storage is 1,749 kilowatt hour per year. Storage depletion is minus 16.7 kilowatt hour per year, and losses is 420 kilowatt hour per year, and annual through output 1,956 kilowatt hour per year. For PV, you can see the rated capacity for PV is 5.20 kilowatt. Color indicates PV output power. Black color indicates 0 kilowatt output from the PV, and the yellow color indicates the higher value output from this PV, and the much higher value is 6. So when you move your cursor onto this yellow color, then you can see the value on your display. In this utility, annual utility bill comparison for the base case and current case simple, and you can save the value 7,735.38 during consumption charge. Demand charge, the value is 84.90 for base case, and the current case is 2.38. So you can save this value is 82.52. Demand response is 0, fixed rate 96, and also for current case is 96, so you can't save any value. Overall, from the base case, this value is 8,392.45, and with the help of current case, you can see the total cost is 574, and you can save 7,817.90. This is consumption rate, and this is demand rate, and the color indicates the value of consumption rate and the demand rate. This value is for the annually. If you want to see the monthly, you can see the monthly profile. For the maximum value, color indicates this value. The peaks charge, energy and demand charge indicates by blue color. By monthly table and by demand limits. Click onto system converter and see the capacity of inverter, rectifier, inverter output and rectifier outputs. The maximum output from the rectifier is 1.4 kilowatt and its color indicated by dark red. At this place, this value is 1.35 kilowatt. And in the inverter, so inverter output is maximum output is 1.2 kilowatt and it's shown by also red color. At this point, only red color. This area is very less, so you can see the output from the inverter. The emission of gases from this entire system. The carbon dioxide value is 150 kilogram per year. Carbon monoxide 0 and sulfur dioxide is 0.652 kilogram per year. Nitrogen oxide is 0.319 kilogram per year. So you can see the emission results. Also, you can draw a scatter plotter, delta plotter, table, exports, and copy dispatch log. You can see the time series plot. Click on to these options for hourly, monthly profile of monthly profile of from January to December, DMAP of this system, histogram, CDF graph, and DC curve. You can change this global solar to AC primary load and see the graph. If you want to create your proposal, click on to create your proposal and fill the details and move next. Give your name, your title name and email address, your phone numbers and other details. Similarly, fill the form and choose your report format in letter form, legal form and A4 size and click and create your proposal for creating your system. Is any other queries regarding the software? Please ask using chat box. You can anytime go to design page and result page using these tabs, and you can see the details of each and every components. Click on to it and see the components property and details. And you can add another value using these options. Is any queries? Please ask using chat box. Is any queries? So you can use this software for 21 days free trial. So let's moving forward to end of this presentation.